Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will solve simultaneous equations by elimination. So let's look at these two equations here. Two simultaneous equations. We want something that solves this equation and at the same time solves this equation, a value for x and y. So we learned in a previous video substitution. Well, that was when you had x or y as the subject of the equation. The problem here is that neither of these equations have x as the subject, nor do they have y as the subject. They're not written in the form x equals something or y equals something. In fact, it would be pretty hard for us to rearrange and put them in that form. It would get a bit messy. So instead, what we're going to do is use the same sort of process. What we want to do is get rid of one of the variables, so we're left with one equation and one variable that we know how to solve. So what I can do is I can subtract these two equations here. So if I subtract everything, I go 3x minus 3x is 0, minus 4y minus 2y gives me minus 6y, 7 minus 37 gives minus 30. So by subtracting this bottom equation from the top, I've got rid of the x's. I'm left with an equation that just has y's. It's super easy to solve. All I have to do is divide each side by -6. I have my y value. So to find my x value, I substitute into either equation. So I'm just going to substitute into the top one. So I get 3x minus 4 times y, which is 5, equals 7. 3x minus 20 equals 7. And you know how to solve from here. You add 20 to both sides and then divide by 3. You get x equals 9. So the solution to this equation is x equals 9, y equals 5. How easy is that? So we were able to eliminate easily because the x's had the same coefficient in both equations. But what about if we didn't have that? Let's now look at this pair of simultaneous equations. Once again, we want a solution to this equation that's also a solution to this equation, a value for x and y. Once again, neither x nor y is the subject of either equation, so substitution will be pretty hard. What we're going to do is use elimination. Now, it's not as easy as this example because the x's don't have the same coefficient in both equations. Similarly, the y's don't. So when that happens, to use elimination, we need to multiply one or both equations so that the number in front of x is the same. So what I can do is I can multiply this first equation by 3. That will make the number in front of x 6. And I can multiply the bottom equation by 2. That'll make the number in front of x -6. So it'll be like the same number in front and I'll be able to eliminate easily. So let's go ahead and do this. So multiplying the top equation by 3, you have to multiply everything by 3. 2x times 3 gives me 6x minus 5y times 3, 19 times 3. So let's multiply the bottom by 2. Minus 3x by 2, 4y by 2, and negative 18 by 2. Now I have the x in both equations has the same number in front of it, 6. So I can eliminate easily. So in the previous example, I subtracted because 3x minus 3x is 0. Here I don't want to subtract. 6x subtract minus 6x won't give me 0. Here, what I want to do is I want to add the two equations together. Because 6x plus negative 6x is 0. Minus 15y plus 8y is minus 7y. And then 57 plus negative 36 is positive 21. Once again, I have one equation with one variable, super easy to solve. I just divide each side by -7. Now I need to substitute that into either equation. So I'm going to again choose the first one. So 2x minus 5 times y equals 19. 2x plus 15 equals 19. You know how to solve from here. You get x equals 2. So the solution is 2 minus 3. The point is, if you don't have x equals or y equals for either of the equations, you eliminate one of the variables. You eliminate whichever one has the same coefficient in front of it. If they have the same sign, you subtract. A different sign, you add the two equations together. All right, let's look now at a worded problem using elimination. So we're now going to solve this problem here. From the canteen, 2 burgers, 3 cans of Coke, $20.40, 3 burgers, 5 cans of Coke, $31.50. We're going to find out how much each item costs. So just as we did for substitution, our first step is we let x equal one of the things we're trying to find. So here we want to find the cost of a burger, and we also want to find the cost of a can of Coke. So we let one of them be x and one of them be y. It doesn't matter which way around. So secondly, we're going to turn this information into two equations. The magic number with simultaneous equations is 2. So 2 burgers plus 3 cans of Coke cost $20.40, and then 3 burgers plus 5 cans of Coke cost $31.50. So we're going to solve this using elimination. Once again, neither x nor y has the same coefficient in both equations. So we need to multiply one or both equations. So this time, I'm going to make the y's have the same coefficient. So I'm going to multiply this top equation by 5 and this bottom equation by 3. Then the coefficient of y in both equations will be 15. It wouldn't matter, you'll get the same answer is if you decided to eliminate the x's, you'd multiply top equation by 3, bottom equation by 2. So let's go ahead and multiply the top equation by 5. So once again, I need to multiply everything in the equation by 5. And now I'll do the same to the bottom equation, multiplying it by 3. Once again, I need to multiply absolutely everything by 3. So now the y's in both equations have the same coefficient, so I am going to eliminate the y's. They have the same sign, I'm going to subtract. So 10x minus 9x just is x, 15y minus 15y is 0, 102 minus 94.50 gives 7.50. So that was easy. I figured out that the cost of a burger is 7.50. Now I need to find the cost of a can of Coke. Once again, I substitute into either equation. Doesn't matter which one. I'll just choose this bottom one here. So I get 3x plus 5y equals 31.50. You know how to solve this. I'm going to get 5y equals 9, y equals $1.80. So I found out the cost of a burger is $7.50, cost of a can of Coke $1.80. I just need to write a worded answer in response to a worded question. So now I've written my worded answer to a worded question, I am done. Thanks so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.